Hello, everyone. This is Ted Keller with your severe weather forecast update for this coming Monday. I think you've been following on Facebook and on YouTube me sharing the Storm Prediction Center outlooks, and that's what you're seeing right up here, the enhanced area that we're looking at for Monday. And this is approximately kind of straddling the Ozarks, I guess, a little bit. This is the area I'm talking about right here. Let me try to get that back. Sorry about that. I lost my screen. There we go. Right in there. That's the enhanced area, with Springfield being right about where that X is. Pretty close anyway. Anyway, enhanced area is the third of five categories, basically, that severe weather could fall into. So it's a fairly rigorous outlook. I mean, it is pretty much saying the severe weather is going to occur in that enhanced area somewhere, if not everywhere within that area. And that's been going up kind of steadily for the last couple of days. By tomorrow, there might be a moderate risk in there somewhere. Hard to say. We'll just be watching the computer models very carefully. So what are the chances for the Ozarks? Pretty good, as I've been indicating. We're looking at two things that make it favorable for severe weather. Number one, we've had enough time for dew points or moisture from the Gulf of Mexico, that's our source region, to come up and a long enough fetch of winds out of the south, in other words, to get some of that deeper moisture up into our part of the world. And if it's not here yet, it will be here by Monday, certainly. And then the other thing is the jet stream. This time of year, we're always in that situation where we still have jet stream winds that are blowing like it's still winter, but at the ground level, it's warming up like it's spring and summer. So that is a very unstable condition potentially. So let's take a look at a couple more things here while we're looking at these graphs. We can show you this. So the machine learning graphics, these are a couple of these are running in the country, one at Colorado State, one at SLU. And basically what it is pattern recognition. Is that so we look at other weather conditions that looked like this in the past, and then they take a look at the storm records and say, well, what happened when the weather was very similar to this? Well, this is the result, at least one of them. This is CSU's, Colorado State Universities. And what you're seeing there, I keep losing my update screen. Hang on a second. There it is. What you're seeing right here is the tornado probability. So that brown area is about a 5% chance within 25 miles of a tornado, which is very close to what the SPC is using right now. And then there's this one right to the right of it, and that is the hail forecast for being significant. And once again, that's got a bullseye right where those supercells and or squall line or both form there in parts of eastern Oklahoma. And then you have just a general wind parameter forecast, which is what this one is right here, which very closely matches the tornado probabilities that we're seeing. So that, again, not too unusual when you have the setup that we have. We can take a look at another product here, which is very close to this. And here I'm just looking at the tornado probabilities, basically, and there's a 5% bullseye according to the SLU model of looking at previous matching there in northwest Arkansas. So what's the general situation? The general situation is one where I think that the dry line, which is that boundary between moist and dry air that's going to be set up in Oklahoma, probably will initiate a few storms, but there are some other boundaries too. And all of these, I think, have a chance of starting as discrete supercells. And if you're looking for tornadoes, that's one of the things you're looking for, is to have discreteness in your supercells. Certainly not the only thing, but a very, very positive sign that you're going to get, tornadoes. So I think there'll be a mixed mode of those to start with, plus then just a good old-fashioned squall line that develops. Some of those individual cells I was just talking about, the discrete ones, may form close or maybe just slightly in the Ozarks, maybe west central Missouri. We'll take a look at the models here in just a second. And then some of those discrete supercells probably down in Oklahoma, and it's all going to kind of merge together in a couple of clusters. The primary one, though, will be a squall line that I think will move through northwest Arkansas and extreme southwest Missouri on Monday night. All modes of severe weather are possible. And when I say mode, I just mean tornado, damaging thunderstorm winds, or hail. So when I say all modes, that means all three of those can get to severe limits with this current forecast setup. Let's take a look at the, I turned that off. Hang on a second. Let me go to, here we go, COD models. There we are. Sorry about that. Anyway, this is the 500 millibar flow. If you've watched these videos before, this kind of gives you kind of a broad setup, kind of tells you what's going on in the atmosphere, what to be looking for. And this is the 500 millibar flow. So as usual, we see a storm in the southwestern U.S. with the colors indicating wind speed. So the darker colors of red and purple are stronger wind speeds. And as you might expect, a lot of times with these setups, we have storms coming in out of the southwest. And I can't clear my cursor for some reason. I don't. There it goes. And let's just kind of move this forward a little bit. This is the GFS model. So if I'm looking for Monday, right there is about 4 o'clock Monday afternoon. So what you're seeing here is a jet maximum right here. Okay. The shear in the atmosphere. Shear is necessary in a deep layer to keep supercells organized, to keep them from raining on themselves and snuffing themselves out. So you need good vertical shear to kind of sweep everything, keep the storm in a way that cycles air through it. So that's not a problem. We've got plenty of wind shear and favorable wind shear for just supercells, not necessarily tornadic supercells, but supercells. That's a no-brainer in this particular situation. If I change, take a look, let's say at the dew points. Remember I was talking about moisture return. So there's that map, and you can see that there is an abundance here. Let me clear that graph out there. So all these darker kinds of shades of blue are higher dew points. That's dry lines right there. We'll take a closer look at that when I change sectors here in a minute. So that's in place. What about just unstable air? We can take a look at that too. So this is just kind of a reading of unstable air. Now, I have seen that these CAPE values, and I've used these before, just overall instability in the atmosphere, are okay in some places, not great in others. There's a couple things going on here. Mostly, though, I think that a large part of CAPE is formed by instability high up in the atmosphere, and that's a little shaky in this one. The temperature decrease with height in the middle part of the atmosphere isn't as great as it could be in your more robust severe weather outbreaks. But having said that, that can change, first of all, and it's not the end-all be-all. I mean, if that's missing, you can still get robust convection and thunderstorms without that, basically. All these were the GFS model. Let's go ahead and take a look at the NAM, which is kind of a short range model, not a mesoscale model. I just changed models and showed you the exact same screen, and it looks very much the same for instability. And if we go check the surface for moisture, dew point, again, deeper moisture values down there in Texas, a little bit more to work with, but still along the dry line up in this area from Oklahoma City eastward to the Arkansas border, it's looking pretty good for a lot of moisture. And then we looked at the 500 millibar, I think, already, but we can kind of look at that. And there's a lot of pattern matching going on here, except this one's a little slower. This would be more in favor of severe weather later in the night and more to the east, like eastern Missouri and eastern Arkansas, if this particular model were to hold true. Let's do one other thing here. Let's change sectors and zoom in a little bit. If I can analyze this correctly here and get this right, there we go. This is going to zoom in a little bit. That's 500 millibars. I'm not so concerned about that because when we zoom in like that, we want to look at a little bit more detail. So here's this CAPE I showed you earlier. Again, this is for 4 o'clock on Monday afternoon. You notice there's a couple of pockets of unstable air right here. And let me get my telestrator back up here. There we go. So yeah, right in here is where we're looking at some unstable air developing. And I want to make a general comment about this setup too in here in just a minute, but that's okay. I mean, if thunderstorms were to fire in those little pockets, they would most likely be severe in this environment. Let's take a look at the significant tornado parameter. This kind of combines a bunch of parameters together, including instability, low-level shear. Notice that it's trying to paint an area up here to the north of Springfield, where, let's see here, try to get that erased. I don't know, my telestrator won't erase for some reason. Anyway, boy, I'm having some problems with this today. Should just take my command. It doesn't. Anyway, the area I'm trying to talk about, let's see if I can draw additionally. I can. Okay. That area right there where those yellows are showing up, that's an area along kind of a warm front that we'll have to watch for individual storm development. So that's early on. That's 4 o'clock in the afternoon. It could be a couple of isolated supercells north of Springfield that actually could get a tornadic foothold if they develop. And then the major action would be storms that fire through Kansas and Oklahoma that move in later that evening, even into the overnight hours for you folks that are east of Springfield, southeast of Springfield. North central Arkansas would be an example of that. I'm going to close this window real quick and open it back up in hopes that I can reset that telestrator screen here. Let me see. We want this one. Let's see if that did it. It did. Okay. Will it erase? Yay, okay. So that, zooming in, that is the NAMS version of that. Now, the GFS doesn't have that particular parameter, but it does have instability, and you can see pockets of it developing out here where your CAPEs are not great. maybe 1100, 1152 there. That's okay, actually. But, we start getting in the springtime, it's not uncommon to get 2,000, 3,000 capes here in April. We're not quite there yet. But again, this is more than enough with the shear that we're being given. The comment I wanted to make about this before I sign off for today is I want to go back to the whole U.S. view here and take a look at that 500 millibar flow. And I want to make one comment about this type of setup. So this type of setup is where the trough of low pressure, that's where these winds kind of dip down with heights. That's what this is. This is a trough of low pressure, okay? So when the tilt on this is like this, if I draw a line along the minimum area like that, that's called a positive tilted trough. So on positive tilted troughs, you can get short waves, which are like this, that move around the flow. That's where those little wind speed maximums are located, like this one right in here. That can really initiate pretty bad severe weather given the other parameters are in place. But what you're not going to get with this kind of setup is a deep area of low pressure at the surface. You're going to tend to get kind of strings and lines of storms that have little bowing segments in them once things finally get going. So this isn't the best discrete supercell setup in the world, although one or two may develop. But if this trough were tilted the other way, if it were like this, where the maximum winds were coming in along the backside, that would favor deep low pressure development at the surface, and that would get this low level winds, which are so important for potential tornado development, to turn in a way that would actually favor tornadoes. So in this case, that does not exist. However, when you get closer to the event, small scale features are often very, very important. So it's going to be interesting to watch this. So bottom line, if you're in the Ozarks, severe weather, maybe isolated cells by as early as late afternoon to early evening in a few select locations, probably north and west of Springfield. And then the main show is when storms develop out through Oklahoma, maybe southeast Kansas later that evening, and sweep across the Ozarks. Again, all hazards are possible. This is today's update. I will likely bring you another video update tomorrow. Thanks for watching. We will see you later.